Okay, today we are going to discuss a very important numericals of electrostatics. The numerical the statement is this: two opposite corners of a square carry capital Q charge each, and the other two opposite corners of the square carry small q charge. So this is the square. Okay, two opposite corners of the square carry capital Q charge each, and other two opposite corners carry small q charge each. Okay, if the resultant force on small q is 0, if resultant force on any of the small q is 0, how are capital Q and small q are related? So what is the statement? The two opposite corners of a square carry capital Q charge each, and other two opposite corners carry small q charge each. Such small q charge each. That means this is the square. Okay, we know that square have the equal sides. The two opposite corners carry capital Q and capital Q charge, and other two opposite corners carry small q and small q charge. Okay, it is said that if the resultant force on small q is 0, how are capital Q and small q are related to each other? Okay, this is the square. I give the name A, B, C, D. So this is side A, this is side A, this is side A, this is side A. Okay, that means distance AD is equal to small a, AB is equal to small a, BC is equal to small a, and DC is equal to small a. These two opposite corners carry capital Q charge each, and these two opposite corners carry small q charge each. If net force on charge small q due to discharge and discharge is equal to 0, if net force on discharge due to discharge and discharge is equal to 0, then we have to find out what is the relation between small q and capital Q. Okay, this is capital Q, this is small q. Both are positive, therefore this capital Q repel this small q, and this force is called Fa. Why Fa? Because this is the force on charge small q due to charge capital Q at A. It is called Fa. Its direction is along AD. This is charge capital Q, this is charge small q. This charge capital Q repel the small charge small q. So this is the direction of. So this is, in this direction, this repel. What is the direction? It is CD. This charge is called FC. Now you see, the direction of Fa and FC are 90 degree to each other. Why? Because it is a square. What is Fa? K small q capital Q divided by distance square. What is distance? This is the distance. This distance is taken as small a. What is Fa? Small k, it is a proportionality constant. Small q capital Q divided by a square. What is the direction? Direction is along AD. This is AD. Now what is FC? Again small k capital Q, small q divided by distance square. What is the direction? Direction is along CD. Okay. Now if you see the magnitude of Fa and FC, K small q capital Q by a square, K small q capital Q by a square, their magnitudes are same, but they are not the equal forces. Why? Because the directions are different. Now what is the angle? This is the symbol of the angle. What is the angle between Fa and FC? So this is the direction of Fa. This is the direction of FC. Yes or no? What is this angle? This angle is 90 degree. So therefore angle between Fa and FC is equal to 90 degree. and magnitude of FA is equal to magnitude of FC. Magnitude of FA is equal to magnitude of FC. Yes or no? What is magnitude of FA? K small q capital Q by A square. What is magnitude of FC? K small q capital Q by A square. Okay. Now what is the resultant? Complete the parallelogram. Complete the parallelogram. Okay. This is one vector FA. This is one vector FC. They have equal magnitude. That means they have equal length. I complete the parallelogram. Again, this parallelogram is again becomes a square. So what is the resultant? F1 is the resultant. F1 is the resultant. If two vectors are represented by two nearby sides of a parallelogram, then diagonal passing through the point represents the resultant of FA and FC. That means F1 is square root of FA square plus FC square is equal to root 2 FA. If two vectors are perpendicular to each other, what is magnitude of resultant? Square root of one vector square plus other vector square. FA and FC, they are perpendicular to each other. What is their resultant? It is F1. What is F1? Square root of FA square plus FC square. Their magnitudes are same. So FA square plus FA square. So therefore it is root 2 FA. Since magnitude of this vector and magnitude of this vector are equal and this angle is 90 degree, what is this direction? It makes an angle 45 degree or it makes an angle 45 degree. This is 45, this is 45. That means it is along BD. What is the direction of F1? Direction is along BD. Or we can say that the direction of resultant force bisect the 90 degree between FA and FC. Okay. So what is F1? F1 is a resultant of FA and FC. What is the direction? Direction is along BD. What is magnitude of FA? It is square root of FA square plus FC square. So root 2 into FA. Okay. Now this charge is positive, this charge is positive. This charge repel this charge. In which direction? Along BD. This small q and this small q also repel each other. So this is FB. Because we have to find out net force on this charge 0. Therefore this charge repel this charge. This force is FB. What is the distance of separation between two charges? According to Pythagoras theorem, BD square is equal to BC square plus CT square. So therefore D square is equal to A square plus A square. So BD is equal to root 2A. So what is magnitude of FB? What is magnitude of FB? It is proportionality constant. Small q into small q. Small q into small q. Therefore q square. What is distance of separation between them? Root 2A. Root 2A whole square. Okay. That means k q square by twice A square. What is the direction? Direction is along BD. Now you see, at the point D, two forces are acting. One is the resultant force F1 and one is the force FB. Both of them are parallel to each other. Yes or no? What is the direction of FB? It is along the line BD. What is the direction of resultant force F1? It is also along the BD. That means they are parallel vectors. If two vectors are parallel, what is the magnitude of resultant? Magnitude of one vectors plus magnitude of other vectors. If two vectors are parallel, what is the magnitude of resultant? Magnitude of resultant is equal to magnitude of one vectors plus magnitude of other vectors. So what is the net force at the point D? It is simply FB plus F1. But according to question, what is the resultant force? Resultant force should be 0. Therefore, FR is 0. That means FB plus F1 is equal to 0. What is FB? K q square by twice A square. What is F1? K root 2 small q. আসলে আমি F1 টো লিখিছিলো K root 2 F1 K root 2 FA লিখিছিলো. What is FA? small q capital Q by a square is equal to 0. I take k q by a square common. I will get this. Is it clear? This cannot be 0. Therefore, this must be 0. That means small q is equal to minus 2 root 2 capital Q. Is it okay? Is it clear? আজি এই নিউমাৰিকেলটো ইয়াতে ষ্টপ কৰিছোঁ। মই PDF ফাইলটো তোমালোকক দি দিম, লিখিবৰ কাৰণে সুবিধা হ'ব।